When The Big Bang Theory first aired in 2007, few could have guessed that a sitcom about four geeky scientists and their social misadventures would become a cultural juggernaut. The show gave us quirky characters, memorable catchphrases, bazinga, and endless laughs. But behind the comic timing and awkward romantic escapades, something unexpected was happening. Real physics was being slipped into primetime television. That's right. Hidden beneath the cosplay, comic books, and Halo Night snacks, The Big Bang Theory often featured accurate, legitimate physics, sometimes even deep, complex ideas from theoretical science. And while the characters, particularly Sheldon Cooper, might be exaggerated caricatures, the science they discuss isn't always just technobabble for laughs. Let's explore the real physics that occasionally took center stage. 1. A sitcom with a scientific consultant. First, it's worth noting that the show had a secret weapon: David Saltzberg, a real-life physicist and professor at UCLA. He was the show's scientific consultant and the unsung hero of The Big Bang Theory's scientific credibility. Saltzberg was responsible for ensuring the whiteboards were filled with real equations and that scientific conversations made sense, at least to those with a physics degree. So when Sheldon or Leonard talked about string theory, quantum mechanics, or astrophysics, there was often a kernel of real science there. Not every detail was perfect, of course. It is a sitcom, but it was surprisingly faithful for a show designed to make people laugh, not prep for the GRE. 2. Sheldon Cooper and string theory. Dr. Sheldon Cooper, the most eccentric and brilliant of the gang, works on string theory, which is a real, and highly speculative, field of physics. String theory attempts to reconcile general relativity, Einstein's theory of gravity, with quantum mechanics. In essence, it proposes that the fundamental particles of the universe aren't points, but tiny vibrating strings. In the real world, string theory is both mathematically beautiful and experimentally unverified. It's a theory full of potential, extra dimensions, multiverses, supersymmetry, but with no clear experimental proof, which makes it controversial. Sheldon's frustration with the lack of breakthroughs is, ironically, quite accurate. Many physicists in real life also question whether string theory can ever be tested. Still, the show uses it as a brilliant character detail. Sheldon's obsession with theoretical purity mirrors the real-world criticism that string theory is more about mathematical elegance than empirical science. 3. Quantum mechanics, Schrödinger's cat, and real-world applications. One of the most accessible and recurring physics themes in the show is quantum mechanics, the physics of the very small. In one memorable episode, Sheldon explains the famous Schrödinger's cat thought experiment to Penny. He uses it as a metaphor for their ambiguous relationship status, both dating and not dating, until observed. This is real physics. Schrödinger's cat is a cornerstone of quantum weirdness. It demonstrates the idea of quantum superposition, that particles can exist in multiple states at once until measured. The cat in the box is both alive and dead, until you open the box. This explanation, simple, elegant, and tied to a real relationship scenario, is perhaps one of the show's most brilliant moments of blending quantum physics with pop culture. 4. The Large Hadron Collider and particle physics. In Season 2, Leonard and Sheldon are invited to visit CERN, home of the Large Hadron Collider, LHC, the world's largest and most powerful particle accelerator. The episode aired just as the LHC was gearing up to search for the elusive Higgs boson, the so-called God particle. The LHC, located near Geneva, Switzerland, smashes particles together at near light speeds to probe the fundamental nature of matter. And yes, physicists really did worry, albeit only briefly and not very seriously, about whether it could create black holes, a fear Sheldon jokes about. When the Higgs boson was discovered in 2012, it confirmed part of the standard model of particle physics, the theory describing how particles and forces, except gravity, interact. The show celebrated this kind of science not with fanfare, but with nerdy enthusiasm and subtle references that fans appreciated. 5. Astrophysics, dark matter, and space-time. Raj Kuthrapalli is an astrophysicist, which allowed the show to sprinkle in discussions of planetary science, dark matter, and cosmology. These aren't just sci-fi buzzwords. They represent some of the most important real-world mysteries in physics today. For instance, dark matter makes up about 27% of the universe, but it doesn't emit or absorb light, making it invisible. We only know it exists because of its gravitational effects. It's one of physics' biggest mysteries, one that Raj might actually be working on if he were a real researcher. In other episodes, topics like space-time curvature, black holes, and exoplanets are brought up. The show never goes full Neil deGrasse Tyson on us, but it introduces these ideas just enough to intrigue curious viewers. 6. The Doppler effect, and that Halloween costume. Who could forget Sheldon's infamous Doppler effect Halloween costume? That weird whooshing sound he makes, that's real physics, too. The Doppler effect describes how waves, including sound and light, change frequency when the source is moving relative to the observer. It's why a siren sounds higher-pitched when approaching and lower-pitched when moving away. This principle is used in radar guns, astronomy, measuring star movement, and even in weather forecasting with Doppler radar. And Sheldon wearing it to a costume party was not just Pete Geek, it was a real science joke in costume form. 7. Equations on the whiteboard, not just gibberish. In the background of many scenes, especially in Sheldon and Leonard's apartment or at Caltech, viewers can spot whiteboards filled with complex equations. These aren't just props. Many are legitimate physics problems, from quantum field theory to statistical mechanics. David Saltzberg often updated these boards to reflect real-world discoveries or to connect with the episode's dialogue. There were even Easter eggs for those with a sharp eye and a physics degree. Final thoughts. A show that made physics cool, well, sort of. The Big Bang Theory was never intended to be a science documentary, but it did something extraordinary. It brought real physics into millions of living rooms around the world, often without people realizing it. It celebrated curiosity, intelligence, and the beauty of science, even while poking fun at the awkward social skills of its protagonists. Did it stereotype scientists? Sure. Was it always scientifically perfect? No, but it sparked interest, encouraged questions, and gave science a seat at the pop culture table. And in an age of misinformation and scientific skepticism, that's no small feat. As Sheldon Cooper might say, it's not just a show, it's a quantum leap for science communication. Would you like this formatted as a PDF or turned into a presentation?